Hello. Welcome to part 2 of our Spotify name displayer on W5100S-EVB-Pico 2. In this video, I will guide you on how to use I2C devices such as the LCD 1602 on W5100S-EVB-Pico 2 with CircuitPython and display our Spotify name on the LCD display. This video will be separated into two sections, which are the hardware introduction and configurations and the CircuitPython codes. Make sure you have watched my last video on Spotify Web API before following this guide. Now, let's get started. The LCD 1602 module is a LCD display module capable of displaying 2 lines of 16 characters each. In this project, we will use the I2C version of 1602 module, which allows using 4 pins instead of 7 to connect to the Pico 2 board. In short, the I2C protocol allows messages to be transferred from one device to another by just using 2 lines of wires, which are the serial clock and the serial data. To operate these devices, you can either find supported libraries on the internet or read the datasheet of the device. On the W5100S-EVB-Pico 2, there are 2 I2C interfaces available for controlling I2C devices. For our project, we will be using GP2 for SDA connection and GP3 for SCL connection. After connecting the 2 pins to the respective ports on the board, you should also connect the ground pin and connect the voltage pin to VBus, as our modules runs at 5 volt. The connection on your board should look like this. If you connected successfully, the power LED and the monitor should both turn on. Now, let's go back to CircuitPython for the project. Let's return to the codes in our last video. According to the video, we have successfully returned our profile name from our Spotify account. Later on, I will explain how to use I2C on CircuitPython by following this guide. Following the guide, let's start by creating an I2C class by binding GP2 and GP3 to the initialize function of bus I/O library. Next, we need to ensure the R program is locked with communicating with the specific device located on the pins. Use a while loop and the I2C try lock function so that if I2C is not locked, the while loop will keep on running until I2C is locked. Next, we need to scan for the addresses available on the I2C device for our board to write to. Use the I2C scan function to locate the addresses and store them in hexadecimal format. Let's try comment our previous code on Spotify API and simply print out the address for our I2C device. You should see in the terminal that there is only one address, and the address is at 0x27 in most cases. This will be the address that we will be writing our data to. Next, let's use this address with functions that the 1602 LCD module supports. As Adafruit's library bundle does not include 1602 LCD Library, I used other open source library from GitHub for this project. During my research, I have came across a HD44780 library on GitHub, which the HD44780 is the screen on the 1602 LCD without the I2C converter. After importing the library, there are a few changes I have made in the source code for it to work in our program. Later in the video, I will explain each steps of my modifications inside CircuitPython. First, in the source code, I imported the math library and removed the bus_device library as we will not be using it. Next, as I have faced problems from using the bus device library, I have decided to change the initialization of the class. I removed the I2C device function and store the I2C object and address inside the HD44780 class using bus I/O library. In the underscore write to I2C function, I rewrote the way on how the I2C device sends the byte data to the address and changed the value inside time sleep function as the original sleep time printed garbled character on the LCD screen. You can find a more detailed explanation on the codes in the Adafruit's website about I2C device. I also increased the time in _strobe function for avoiding the LCD screen to malfunction. Lastly, I changed the string write function of the library. In the GitHub library, the string write function specifies the line to write the string to, and if the word length exceed the max width of the line, which is 16 characters, the remaining letters after the 16th character will not appear. For my code, I first categorized the write function based on whether the total string length exceeds 16 characters. If the characters are less than 16 characters, we follow the GitHub library on printing the string. If the number of characters exceeds 16, then we will need to form a new algorithm for printing the string. Starting with the initialization, I first find out the number of lines needed to print the whole string. I also defined a variable for the number of filled lines so that if the filled lines is 2, it means that both of the lines are filled with characters and we need to clear the screen and reset back to the first line. Lastly, the start and end variable indicates the start position and the end position of the string character list that will be printed on the given line. We then define a for loop to print all the strings. If the number of lines exceeds 2, the filled line variable will reset to 0 and spaces will be printed to the 2 lines. To reset the lines, we need to first indicate the address of the line that we will be writing spaces to, and then write space characters on the lines. In the _write function, we use 32 as the write data because 32 is the ASCII code for blank space. After that, we do the same for printing the string, where we first find the line address first before printing the characters. This for loop prints the string from start position to end position of the current iteration. Lastly, update the start and end position of the characters in the string so that we can print from the new positions in the next iteration. The library is now completed. Let's go back to our code py file. Import the library to the main code and initialize the display. Before printing our name, let's try out if the display works or not. Use the function displayWrite to print a hi message on the LCD screen. Run the program once, and your display should show a hi message. Lastly, let's repeat the process of obtaining the auth code from Spotify and display our name with a welcome message. Start by uncommenting the codes to get the URL link for the authorization code. Copy the code and paste it to code variable inside main program. Uncomment the part for exchanging token before rerunning the program. After obtaining the token, paste your token to the auth token key in your secrets.py file under your lib folder. Comment the token exchange section again and make some changes on the displayWrite functions. First, let's uncomment the section on making a request to obtain the Spotify name. We will store the name under my name variable. Next, let's display a welcome message on the first line on the LCD screen and display our name on the second line. If the program runs successfully, you should see a welcome message with your display name on the LCD screen. This is the end of this video. I hope that this video not only helps you to operate the 1602 LCD screen, but also helps you understand more about operating I2C devices in our board. If you enjoyed the video, please like and subscribe to the channel for more videos like this. As usual, you can find the links related under the description. Our next video will be making the full name displayer, where our LCD screen will display the current song that the Spotify web app is playing. A controller knob will also be featured as a local controller to the Spotify web app, but functions such as pausing or skipping the song requires Spotify Premium in order to operate. A more in-depth explanation will be provided in the next video. I will see you soon.